Okay, so we're going to do some problems involving inverse trig functions. Before I start the problems, let's review an old idea that we've talked about. Let's say I have a function and it's going to use alpha as its input, right? And then it spits out an output called beta, okay? So if this function is 1 to 1, then it has an inverse function. And in here, we're going to place its input. But if beta is the output of f, then that means that beta would now be the input of f inverse. And now this function is going to spit out alpha. Okay? So, problem number 1, we're going to write theta. We'd like to write this angle theta here as a function of variable x. All right? So we see that we have this triangle, and I have these two sides that are given on the triangle. All right? So if this is angle theta, then this is the opposite side. Okay? So this would be the opposite. And this side here would be the adjacent. Okay? So we could relate these three together by using the tangent function. We know that the tangent of theta, okay, would be what? Opposite, which would be x minus 1, divided by the adjacent, which is x squared minus 1. Okay? So this statement is similar to this one. You've got the tangent of theta, and in this statement, theta is acting as the input for our tangent function, and all of this fraction is acting as the output, similar to beta. So, if I want to isolate theta, then now I can use the inverse tangent function. Okay? I now know that I could take the output for tangent and now use it as an input for inverse tangent. And this function would now spit out theta. Okay? So we've accomplished what we set out to do, because we have now been able to isolate theta, and we have now written it as a function of x. Okay? Okay, now, next example. We're trying to evaluate this function here. I've got a cosecant function, and here in the parentheses is this value here given in red. And that is an inverse tangent of negative 5/12. Okay? So when I'm done, I should end up with just a number. Okay? So I'm plugging this red number into a cosecant, and I should get out just a number. So what I'm going to do is I'm going to begin by letting all of this here in red be equal to this variable u. Okay? You can use any letter you want. So let's go ahead and write that over here. We let u be equal to the inverse tangent of negative 5/12. Okay? So really, if you look at what we have here up above, this on top is really now equal to the cosecant of angle u. Okay? So all of this in red is just really equal to u. So to complete this task, all we need to do is evaluate cosecant at u. Right? So what do we know about u? You get it? What do we know about u? All right, so u is an angle in quadrant 4. Remember, we learned in class that if you take the inverse tangent function and you plug in a negative number into it, you're going to get an angle in quadrant 4, okay? A radian angle in quadrant 4. Okay? Now, similar to what we did in this last example, what I can do is I can now rewrite this statement in red using the tangent function. I know that the tangent of u is now going to equal -5/12. Okay? Remember, this -5/12 was the input for this function, and now it's going to be the output for the tangent function. U was previously an output, and now it is an input. Okay, great. Now, using that statement, I can build a triangle. Okay, so I've got this angle U in quadrant 4. Okay, now, the sides of this right triangle, well, remember, tangent is by definition what? It is opposite over adjacent. So that means that if this is my angle U in quadrant 4, then this side of the triangle would be what? This would be 5. Okay, so this side of the triangle has 5 units, it's 5 units long, and this adjacent side is 12 units long. Okay. Now, if I wanted to, I could write this as an ordered pair. That little point there would be the same as what? Positive 12 and -5, right? Okay. Okay, now, using this triangle, which has angle U in it, I can now evaluate the cosecant of U. But cosecant is what, folks? By definition, it is hypotenuse over what? Over opposite, right? Okay, so if I look at my angle U here, I do have the opposite, which is here, but I don't have my hypotenuse. Okay. So that hypotenuse is a missing value. Let's call it question mark. Okay. And so now I'll use the Pythagorean theorem. I know that it's 12 squared plus 5 squared equals hypotenuse squared. But that's what? 144 plus 25. Okay. But that's going to give us 169 equals question mark squared, and therefore question mark is 13. Okay, so we've now found the length of our hypotenuse, which is 13 units long. Okay, so now we can wrap this up. We have our cosecant of angle U, and we know that we're dealing with an angle in quadrant 4, so the final answer has to be a negative number. And now we'll just use the sides of this triangle. So hypotenuse is 13, and opposite would be what? 5. Okay? All right, so we have completed our test. We have evaluated the cosecant of the inverse tangent of -5/12. Okay? All right, I'd like to do one more for you, and it's going to be similar to that problem, but now there's going to be variables contained inside. Okay, so if you don't mind, I'm going to erase all this. Okay, so what do we want to do? What did I pick earlier? All right, so I'd like to now write this expression